Alrighty. So, what's that? Number 5. We've got two cars travel in parallel lanes on a two-lane road. The cars' motions are represented by the position versus time graph shown in the figure. Answer the question using the times from the graph indicated by letters. Alright. Boy, I wish they had made those two different colors. But, okay. At which time do the two cars pass each other? Okay. So, let's think about what does it mean for them to pass each other? Not on the graph, but just like in real life. What has to be true for you to pass someone? Or I think of it as catching someone. They're at the same point at the same time. So, yeah, to pass, you must be at same place, same time. That's good. Because that's one of those kind of hidden criteria that you don't really think about. You know, to catch something, to collide with something, to pass something, same place, same time. I usually use the example of you're going to meet up with somebody. You know, you're going to meet up with someone tomorrow to do something. What do you tell them? You tell them where to be and when to be there. You know, think about how many times you've gotten in trouble maybe with whoever picks you up from school because you were there, but you were there at the wrong time or something like that. So place and time. So that's the key to, I think you can probably, I tend to not like to do the multiple choice for you, but at which letter times, if any, does car 1 momentarily stop? So from a position time graph, how do we know the speed or the velocity? Well, we should probably show that we understand what velocity is. So I'm going to say velocity is the rate the position changes on a graph of position versus time. This is the slope. So this one really doesn't have much of a how, right? It's got a lot of why to it. But the slope of the position time graph is the velocity. So that's the key to part B and C here, D and D. And then E is the same idea also. Where are the two slopes are the two slopes almost identical? Now, car 1, I would think it's easy to tell the slope, right? Because what's true about car 1's slope? It's constant, which means their velocity is constant. What about car 2? Not constant, hence the curve, right? In fact, it's an increasing positive slope, then a decreasing positive slope, then a increasing negative slope to a constant slope. So I think I'll put that in my how part, but that could be as part of my why. Could do a screenshot, but yeah, I think I'll do a screenshot and put it in there. That helps me with part E. So hopefully this doesn't cause my computer to crash. It's been known to. There it is. I think I'm waiting for my computer to catch up to me now. Oh, and one thing I realized this morning when I was using this is I have the old rubrics in this document. Sorry about that. I forgot that I did. So, this is actually, up to here. I'm going to erase this one. This is a positive increasing slope. So these are the slopes that I'm talking about here. Here, this is positive but decreasing. Here it's 0. Here to here, it's negative and increasing. And here it's negative and constant. Wow, this one is just positive and constant. Is that good? All right. I think that's probably all I would do for 5, to be honest. All right, so we're doing number 9 here. We've got a bus with this mass, and it moves at this speed, and we're asked how fast. So fast, we think speed right away, right? May as well move it or have the same momentum as the bus. So do they care about the direction here? No, but we're going to assume they're moving in the same direction. So we don't have to worry about that because we know momentum's a vector, but we're just interested in the rate it's moving. So go with number 9. I'd probably start off by showing I understand what momentum is. Momentum is about inertia in motion. While momentum is a vector, in this case, we are only interested in the magnitude. Probably I need one more line in there that ties my y to the problem because I'm kind of generic right now. So I should think about what's involved in this problem. And we have the school bus, which is very massive. What does it mean to be massive? Have a lot of mass. To be big means you have a lot of volume, right? So massive means a lot of mass. Hence why shot puts don't have to be that big, because they're dense, so they can have a lot of mass without being huge. So the bus is very massive. It doesn't have, and it's moving not too fast. The baseball, how massive is it compared to the bus? Very little, very small mass. So what must be true about its motion to have the same momentum as the bus? Has to probably be really fast. So I'm going to say the bus is massive, so but moving slow, So the low mass ball must be moving fast to have same momentum. So now I've tied it directly to this problem, and I've really shown I understand what's going on, beyond just I can throw it into equation. Can I scroll up? We good? So my equation, from my equation sheet, is going to be the momentum equation. Says momentum equals the inertia times the velocity. Notice the lowercase p. And I know that the momentum of the bus must equal the momentum of the ball. And I dropped my vector signs because, as we said in our y, we don't care about the directions, just the magnitude. So here I have the mass of the bus times the speed of the bus equals the mass of the ball times the speed of the ball. Momentum. 18,200 kilograms. I don't draw the comma just because people mistake it for a decimal point. And 12.5 meters per second. Mass of the ball. Now be careful, you have different numbers than me, right? So if you're following along doing this with me, make sure you put your numbers in, not mine. One of the common things is, Mr. Cochran, I got it wrong, even though I did exactly what you did. Well, because you did it for your numbers, I did it for my numbers. So be careful of that. Okay? 0.142. And then I don't know what the speed of the ball is. Oh, but I can solve for that. And I'm going to trust that you guys can do the algebra that's there, right? All right, so number 11 is the last one. And we've got this baseball, and we know its momentum, and they want to know its speed just before landing. If it's just before landing, what direction would it be moving? Yeah. Your exit ticket just came live. Can you fill that out before leaving?
I'll be back.
Yep, that'd be fine. Either way, as long as you get it done by the end of class. What is this, number 11, right?
Yeah.
So momentum is about inertia in motion. The ball is moving downward. So its momentum is down since velocity and momentum always in the same direction. And makes me regret that I just erased this. And now I can substitute in. They tell me the momentum 0.76. So I'm actually taking down as positive, so that I don't have to deal with any signs. They tell me what do they tell me? The mass 0.15. And they want to know what the velocity is, so what the speed is. And then I just solve.